Okay, thank you. So last time we began introducing the topic of exceptions in Java. So we went through a couple of concepts, especially the workflow of how the exceptions are generated, thrown, and captured. So we used the catching terminology to refer to this idea of capturing that exception that has been thrown. And we begin discussing about the possible actions that we can do as developers of the program that we are creating or maintaining with respect to those exceptions. So one of the things that we can do, of course, is throw exceptions. That'll be the use of the throw keyword. We saw that, and perhaps even more importantly, we can also catch those exceptions. Every time that you have a piece of code that would possibly be throwing exceptions, you need to put that code, those statements inside the try block. With a try block, you need to have one catch or a finally block or both. And the more typical kind of combination that you would have would be the try catch block. So the try, again, as I said, would bring the statements that could possibly throw that exception. And in the catch block, you would essentially be trying to capture or treat or handle that exception or those possible exceptions. It's also possible to have more than one exception being generated inside the same try block. And the possible ways in which you would be handling those different exceptions would be either using a common exception type, so a parent type that comprises all the possible exceptions. This is most of the case not ideal. You want to usually be more specific. So you can also make use of the multiple catch blocks, and that allows you to have essentially more than one block of catch, and hopefully that takes care of the different exceptions. If they are not part of the same inheritance tree, then you would need really to think about multiple try-catch blocks, which is kind of what you have here in this example, right? So that's also one way in which you could sort of achieve that. With exceptions, we can also nest those try block or try catch blocks, and as the common idea would probably you'd probably think that the reason why you would want to have that is if you would have that outer context where you would want to catch. That's typical when you have sort of a catch-all kind of exception handling. So that would be outside, that would be in the outer block. So that works mainly like a last resort kind of exception handling, and that's pretty much what you see here in this current slide, right? So we will go over some source code that looks pretty much like this one. So I'll just keep this one for now, and I will go over the remaining nodes that we have here, and then I'm going to switch to the IDE, and then we are going to explore a couple of examples that involve the use of exceptions. So as we mentioned before, the finally block is essentially a block that is always or almost always executed, right? So with very limited exceptions to that rule, so that would only actually occur when the program finishes before you reach the finally block. So it is possible that you would call system.exit that would just interrupt the program. So that would be the case where you would not really see the finally block being executed. But other than that, you would always actually see the finally block being executed, right? So no matter what happens, if the exception is not thrown, or if the exception is thrown, so no matter what happens, essentially you would see that block being executed. All right, so we also mentioned about this idea of try with resources, and the try with resources is an additional sort of an augmented syntax that you can provide in the try block. So notice here that at the bottom here we have the try with a parenthesis. So everything that is inside that parenthesis would be essentially variables that would be using instances of classes that would actually require to be closed before leaving this context. So imagine that you are, for instance, reading lines from a file, and And when we are dealing with, for instance, a buffered reader, a buffer reader is a class that would allow us to essentially go over some text sort of file, and we could read line by line. So it's similar to the example that we have seen before using scanner instances. So in that case, you would, after you would be done with the reading of the lines, you would be required to call the close method to make sure that the resource in your operating system is actually properly closed. So that's a required best practice that you need to follow, because the resources in our operating system are limited resources. So you don't really just want to keep increasing the use of those resources, because these are very limited sort of resources, right? So that just means that to some degree the OS has a limited amount of ability of interacting with those resources. Yeah, so here the main thing is the use of the close. So if you see the example here on top, inside the finally block, we have the call of the method close on that object that we have instantiated here. So this is what would be our best practice that I have mentioned. If you go with the try with resources, or in other words, if you actually declare those instances as this one that you see here inside that parenthesis, so then the JVM would automatically close that those resources that are inside that parenthesis for you. So it would, in essence, essentially implicitly call that close when it reaches the end of that try block. So when the last statement, the try block, is finished, then it would just call that, and then we would be done. So the benefit here is really because we're just reducing the clutter in the code, right? So these codes are just way more clear and readable with respect to the code that we have here on top. So we know that we need to close anyway. So it's not like we're like just hiding some important piece of the implementation of the logic, but instead really no detrimental effect in the readability of the code would happen here at the bottom. Let me know if I have any questions so we can move on. So the way that we would be throwing an exception, and we saw that before, would be by using the throw keyword. If you have the need of using an exception that follows a type that is already present in the Java API, of course, you can just go ahead and instantiate one of those exception classes. The typical use of the constructor of those exception types would be to pass a message that's just a string that you pass to the constructor of that given type. And that is inherited from throwable. So pretty much any kind of class that would inherit from exceptions would be able to handle that kind of thing, right? So of course, if you provide your custom implementation, and we will see that, so you would want to also have a constructor that takes care of that. All right, so let's look one more example here. So here we have a person class, and my person class has two fields, name and age. And here I am providing a constructor to that person class that takes the name and the age. And if it identifies that the age is actually not negative, so we would want to specify that using an exception, right? So that's sort of the design choice that we are going with here. So in this case, because this exception here is an unchecked exception, then there is no need for any modification in our code to actually allow that exception to be thrown. So in other words, if I would normally be declaring a throw statement, I would need to also make sure that that constructor or that method, so that rule actually applies to both constructors and methods, would say that it throws that specific kind of exception, right? And we do that because we want to signal to whichever scope that is making use of that method or that constructor that there's a possibility of that exception being thrown. And if there's a possibility, in the case of the checked exception, you would be required to handle that exception. If it is an unchecked exception, you can still actually do that, right? And that's definitely fine to do that. That's a good idea. That's a best practice to catch all the possible exceptions that you see happening in your code. The possible downside of that is just really that you would be adding more and more code that would be handling those kind of exceptions. So some people would argue against these additional code because that's some additional clutter that does make it a little bit more challenging to make sense of the logic of the implementation of the program. So it's not part of the main logic that the program would be following. All right, so let's see another example of an exception. So now we have this checked person, and same as what we had before, we have these two fields here. We are declaring here a constructor that takes those two parameters. And notice that here there's a difference. So here we are saying that this constructor throws this type of exception, right? So this type of exception, actually, we did not show yet. We are going to show that one. But because this is a checked exception, so in other words, that exception is not going to be created as a subclass of runtime exception. And because it's not a subclass of runtime exception, so that makes essentially that exception a checked exception. If that's a checked exception, so that means that every time that you throw this kind of exception, you need to declare in the method that you have that throw, that possibility, and that's what you would see here. All right, so you see that the throw exists here. So this throw statement causes, of course, the exception to be thrown. So that means that we need to delegate essentially that handling of that exception to some outer context, so some context that would be calling that constructor. That'll be one way of taking care of that. The other way would just be, as we saw, using the try-catch blocks. So as I mentioned before, it's perfectly fine to decide about implementing your own exceptions. So you can go ahead and create your exception. The way that you are going to do that is essentially just by declaring a class, as we have done before. Now you need to decide about the parents of that class, right? So what makes a class an exception class is really just the fact that it's a subclass of exception. It might be a direct subclass that type, but it might also be a subclass of some other exception types. So same as any class hierarchy, you can also have the typical hierarchy when you are working with the exceptions, right? We need to decide about the exception that you are creating being a checked or an unchecked exception. So if you wish to have that as an unchecked exception, you would be required to have that as a subclass of runtime exception. If you want the other way around, so that means that you cannot have that under runtime exception, because that makes it an unchecked exception, right? And the opposite is true. So if you have that subclass, that new class as a subclass of a class that is not parent of runtime exception or is not runtime exception itself, so then that would become a checked kind of exception. As with any choice of names for our classes, you want to be describing the sort of type of exception in the class name itself. So that's also a best practice. And you will also be concerned about the use of the constructors. So in this case, you would want specifically to call the super constructor to make sure that you pass the message, because as we said, we have some parent classes that actually make use of that message. So you want to set that message to parent classes as well, and we will see examples of that here in this next example. All right, so in this example here, we finally show that age exception that we were commenting. Notice that this is a subclass of exception directly, so that makes it a checked exception, right? Notice that here we have some value, so you are free to create any field that you find the need to do that. You can declare a custom exception, so you don't necessarily need to follow just that more common constructor that only takes one string, but you can actually take more, as needed. So in this example here, we do that. So we initialize the message and the value. So notice that the value is being declared here, and the message is being passed to the parent constructor. So that's what I just mentioned in the previous slide, right? So you are going to make a call to the superclass constructor, and you are going to pass that message to be able to have that message initialized. So that it will just save that string, and then every time that an instance of that class calls the get message, you would essentially see that message that you have passed. So here on toString, you also see that we are overriding toString just to provide with some information about that given instance of that class. All right, so that's the last slide that we have here regarding exceptions. So now we're going to switch to the examples that we have here. So let's go with the examples that we actually already saw. I believe that was one. Yeah, that was one that we have seen before. That's an example of the use of nested exceptions, right? I have this class except6. I have this main method. I have one initial try block here, and then I have a nested try block, and I have another try block that is also in the same level and same hierarchy of that first try block. So essentially, you have two try blocks that are nested from that first one. So as we saw before, every time that you have anything inside the try block, that means that this would possibly be throwing some kind of exception. In this case, what is triggering that exception is that division by 0 that we see here. So when we divide by 0, the kind of exception that would be thrown would be arithmetic exception, and that is being directly handled here by this first catch block, right? So let's say the closest catch block is going to be the first one that the JVM is going to try to use. But if it actually does not happen to capture, to match the type, so then it would keep trying to find some other catch blocks in the previous blocks. So that's what follows this nested structure here. So for instance, if we would not see this catch handling this kind of exception, so then we would go to the next catch block. That would be this one, right? We're not going to that one because that's not part of the hierarchy, right? So you would just go move to the previous hierarchy, previous level, and that's going to be the one that would possibly be capturing that. As you saw, exception is the catch-all kind of type. So these would actually catch any kind of exception. So because of that, that would for sure be capturing that thrown exception. Okay, we can play a little bit with that code, but before we do that, let's just go over that second try catch block that we have here. So here next we have an array with 5 positions that is being created, and then we saw this example before. I am trying to access an illegal position in that array because Java uses 0 indexed positions, right? So that means that my valid position would be from 0 to 4 because I only have 5 positions. So that means that we actually don't have that 5 indexed position on my array A, right? So that would be an illegal access. So that would be the case of the index out of bounds exception. So as you see here, now I actually don't have a matching exception in this case because the arithmetic exception is not matching that type of the index out of bound. So the index out of bound exception being thrown would cause essentially this catch block to be bypassed because it's not really capable of capturing that kind of exception. So then, as before, we would go to that previous level in our nested sort of tree of try blocks. And then again, the same matching would try to be done. In this case, again, this is a catch-all type of exception. So that means that these would be capturing that. And then these would be the block that would be handling. So the statement that you have inside that block would be executed. So after that, you would just go with the flow of the program, right? That's if you reach this point here, that means that you leave that inner block and you just go with the follow-up line. So that's going to be the next line that we would see. So let's execute here these program, right? So just to really try to make sense of a sequence of things that are happening. And the way that we are going to make sense is by observing these print line statements, right? So let's actually, before we do that, let's try to predict what is going to be the output of the program. So if I go again to the top here, the very first thing that is going to be executed will be this statement. So this would always be executed. There's nothing preventing that from happening. The next line is my division by 0. So then my division by 0 is going to generate that exception. Then JVM would try to find a catch block. And then the catch block that's going to be taken care of that is going to be this one here, right? Because division by 0 matches that type. So in this case here, we're just printing E. So E is really just going with that toString. And toString, typically you just get the type. So it's going to be pretty similar to that message that you use with that get message method. So this is going to be printed. And then after we leave that, we are going to go to the next, the follow-up line. So the follow-up line here would be this one, right? Because we have finalized that catch block. So we're going to go to that line. And then I'm going to initialize that array. And then I'm going to try to access that location. That location would be not the legal location. So then as we saw before, this would be not capturing that kind of exception. So then these lines would be skipped, right? So I would not see this print line here printing. Then I'm gonna go to this catch, and then I would see this one being printed, and then finally this one being printed. So the sequence of things being printed will be this one, right? And then this one, and then not this one, and then this one, right? So this one would not be printed, and we're going to see this one printed, and then finally this one. Let's see if that's really the case. Let me run this program here to see if that matches our predictions. So we see that that was the first one that we mentioned. That was the second one that we mentioned. We see them here, right? And then this one would not be printed, right? And then this one will also not be printed. And we have this one. So you see that that's the third one. And finally, that's the last one that is printed, and you see there. So the predictions that we made here essentially matched the output, which is, of course, always a good thing, right? And hopefully you would be able to be doing that as well. And I expect you to actually be able to do that. And most likely to see one question in our exam asking something similar to what we are doing here. All right, let me know if you have any questions so I can move on to some additional examples. All right, so let's see if I have, yeah, I do have, so let's go with that. Finally, 5 here. All right, let me go to that one. So that one is going to be kind of similar to what we saw, but here we need to consider the use of the finally block as well. And also we have 3 levels. So let's see what happens here, right? So let's go to the very beginning. So I have this finally 5 class. Then I have this method. Inside my method, by the way, my main method is really just instantiating an object of that class and then calling that method. That's pretty much it, right? So that's the only thing that we have in that main method. Let me also close this one here. So inside my method here, my try catch finally method, I am creating an array, and I am initializing that array with 1 position, right? So the 1 position is not determined by that 1, of course, right? But this is the element, that's the value of the first position that we have. So I have a series of nested try blocks here, right? So I have these more inner try catch block here. So let's try to make sense of this one first. So here at the very first statement, I am calling print line with an empty string, and I'm concatenating that with the output that comes from the second position. So remember that we use zero index with the arrays here in Java, right? So I'm accessing the second position here, or I'm trying to access the second position here. Will I be able to do that? No, we will not be able to do that because I have just declared and initialized that array with only 1 position, right? So if you try to access the second position, that would be an example of that index out of bound exception. So trying to access an index that is not valid with respect to the size, the number of positions that you have in that array. All right, so when that happens, that means that an exception is going to be thrown. So you will not see this following line executed, right? Because the exception has been thrown. So now the JVM is in that special environment where it is looking for some catch block to handle that exception. We are going to check the immediate catch block that we have here. So those will be those lines that we have. That's part of the same try catch block that we are currently going over. So in this case, the arithmetic exception here would not capture that index out of bound. That's similar to what we saw happening in our previous example, right? So that's not a match. So that means that what's going to happen? These would not be executed, okay? So I will move on to the next level or the previous level, right? So I'm gonna leave these more inner try catch block here. I'm gonna move to the next level. The next level is not going to be the outer, the outermost one, right? So it's the one that you see here in these lines, right? So this is associated with that second level try catch block. So that's going to be the next one that my JVM is going to be attempting to use to capture that exception. And you see that here we have the exception as a type. So then guess what? Yes, that would be a match compared to that index out of bounds that we have seen before being thrown. So good, right? So then I'm gonna see those lines here possibly being executed. So in the first line here, again, one more time, I have a print line, and then I am actually repeating what I have just done before, which means that I am one more time trying to access a position that do not exist in that array, right? So this will one more time throw another exception. That's a new exception, right? That is being thrown, but that's still an exception that needs to be handled. So in that new exception, pretty much the same thing would happen. So I would leave that catch block and I would look for a catch block that would be capable of capturing that exception, right? So do you see any catch block that is actually capable of doing that? We do have one here that is capable of doing that, right? So that's going to be the one that's based on the type again here, right? So you always need to evaluate these this matching, right? The type needs to match the type that you have here in the catch block. In this case, as we have mentioned a couple of times at this point, exception captures any kind of exception. So then this block would be able to capture that exception that has been just thrown. So then I have only one single statement here. That statement here is printing that message. So this is not doing anything that could possibly throw any other exception. So this would just complete without issues, right? So then we are going to move to the flow, the regular flow of the program, which is going to be the finally block, right? So the finally block is going to be the next thing that you would see being executed here in this after this catch block is finished. So here again, I only have one string being printed. So then, so far so good. I would see that printed. And then finally, I would reach the end of this method. And because the execution of this method is pretty much the only thing that we have in our program, so then that means that that's the only the very last thing that's going to happen, right? So again, let's do that check. Sorry, let's do that check. And let's run the program here so we can see if the outputs that we have predicted here would really be what we would be seeing. So let's go from the top again, see what possible print line or print statements we have. So this prints nothing. This one is going to be not printing anything because this would be when the exception would be thrown. So that means that this method would actually never be executed, right? So you're in a way you can think of the sequence of things that the Java compiler would be doing would be to concatenate what you have here with whatever you have on the right-hand side. So you need to evaluate what you have on the right-hand side. So that's when you throw the exception. So you never actually finish that concatenation operation. And of course, these would not be a proper instance of a string that would be passed to your print line. So this print line never prints anything, right? And you see that's really the case here because you don't see anything being printed. We also mentioned that when that happens, now you are in that special exception handling environment, and the follow-up line here inside my try block would not be executed, right? When exception is thrown, you just leave that block, and you possibly will try to find, or the JVM will try to find a compatible matching catch block to handle that. So that's going to be what we would be seeing here, right? Actually, sorry, this is the arithmetic exception. This is not actually capturing that one, right? So we would not be seeing that one. So it would be moving to the next one, the next catch one. The next catch one is going to be this one. So in this one, I would see a match. So then now I would see that catch block be executed, right? So let's again evaluate what you have inside that catch block. But then here again, I have pretty much the same statement that I have in my first try block. And pretty much the same thing is going to happen. So a new exception is going to be thrown. I would not see this statement actually finishing. So that means that I would just leave this block, right? So I would not see this line here executed because my JVM is just looking for a catch block to take care of that exception that has been just thrown. That's a new exception, but that is an exception that needs to be thrown, even if that was thrown inside my catch block, right? So then that's going to be taken care of by this catch block here, right? So the type here matches, so this catches any kind of exception. This print line here has no dependency or anything that could actually throw another exception. So then I would finally see something being printed, right? And you can see here that that's really the case based on our output. And then finally, you will see, so this catch block would finish. That's a one line statement catch block. And then we would move on to the final block. So remember that the final block is always executed, right? So no matter if the exception has been handled or not, so you would see that final block executed. And inside here, you have one more time just a print line with a string literal. So that would, again, just be something that would be printed, right? So you see that happening here. So then essentially our predictions in terms of the sequence and the output of the program have one more time matched, which is good, right? All right, let's try to make a little bit of modification here. Maybe, how about we change this one here, right? So how about we make this one actually into an index out of bounds exception and see what happens now. So we'll the first question is, will that somehow change the series, the sequence of statements that would be executed and also the outputs? And you probably can see that that's actually the case, right? So you would actually see that these will change the series of things that would be executed. So recall that, let's just go back to the top here to make it easier, right? So the very first statement here inside my try catch block is going to throw an index out of bound, right? So if I have my immediate catch block here matching that, that means that this one will be executed, right? So before I did not see this one executing, I will still not see that line executing, but now I will see this line here inside my immediate, my closest catch block executing. So I would see that exception one. This will not throw any exception, right? So when I finish this catch block here, I would move on to the next line, and the next line is not going to be this catch here, right? So the catch is only triggered when you have that new exception being thrown. I don't have any new exception being thrown, so I will not actually see that executed, right? So I'll just move on to the next. And then again, I will have another catch. Again, you don't have anything being thrown here, right? Based on this line here. So you will not really see this executing. But you do have a finally block, and recall that, as I mentioned before, the final is always executed, right? With just that one exception of when the program closes and leaves before actually arriving in that finally block. That's not the case here. So then I will actually see that finally block having that statement printed, right? So yeah, so in other words, let's just one more time try to see the sequence of outputs that we'll be seeing, right? So this one I would not see, this one I will see, this one I will not see, right? This one I will not see, and then this one I will see. Let's just run again and see if our predictions actually match the outputs. And when that does happen, that's something that, of course, makes us very happy, right? Let's see if that's the case. I predicted this one. You see that that's the one here. Good. I said that this one would not go. You don't see that one here. This one would not go. You don't see that one here. That one would go, and you see that one here. But then again, one more time, our predictions matched, and we're happy, okay? Let me make a pause here to catch my breath and also to give you the ability of ask any questions in case you have. All right, so let's move on to our third and possibly last example. So that's going to be this one here, try catch. All right, so this one looks like maybe the longest example that we have for today, but let's go, right? So here, let's take a look first at these main method. So my main method, I am just I'm just printing that R value. R is actually referring to the return value, right? So I am instantiating that class. I'm calling that method. And in this case, of course, I would expect that method to return some kind of value, and then that would be the value that's going to be concatenated with that guy here, and then that's going to be possibly the very last thing that you would see in your program, right? Now let's move on to the top, and here we have that method, that single method that, I mean, other than main, right? Other than main, the single method that we have. So I have I I is just a primitive integer is being initialized as 0. Then I have a first try catch block or an outer try catch block. So notice that here my try catch block comprises all that, right? So that's my first try block. I have a catch clause here, a catch block here, and I have a finally block here. So I'll need to make sense of all those in case we arrive in any of those catch, and every time that we actually arrive at that finally, right? All right, so here I change the value of I to 1, then I print that value. So far, nothing really, nothing that could trigger anything in terms of throwing an exception, right? So I have another try catch finally block here. That's another example of a nested try catch block. Maybe the difference here is that we have a finally inside that inner try catch block here. But let's see how this goes, right? So now I set my I to be 2. And then I go and try to perform a division by 0. So we don't like that, right? So we know that this is something that would actually throw an exception. So the division by 0 is going to throw that, forgot the type, arithmetic exception, right? So arithmetic exception, so that's going to be the type. So let's see what would be the type that we have here in that first catch block. So you see that the type here is an exception. So that means that these would be able to capture that type of exception, because that's, as we saw before, is a catch-all kind of exception, right? So these would be capturing that exception. Okay, so that captured the exception. I skipped that line, right? So that captured the exception. This is a commented line. And then I would be printing that one. So I would see that executed. Then my try catch here finishes, right? So then I'm gonna just move on to my finally block. My finally block again throws another exception, right? So because it throws another exception, so that means that now I need to find a catch block that would be able to essentially make sense of that exception, right? So I need to leave this context that we have here, and we have another context that do have a catch block, and same as before, you would never see this line actually be executed, right? But that's fine. I would have that outer catch block here capturing, so that's an exception type, so it would be capable of capturing that, right? One more time, I am actually generating one more exception. So this time here, actually, I will have no catch block that would be capable of capturing that exception, right? So what's going to happen next? So what happens next is the program crashes and the print stack is printed. No, the next thing that happens is you do have a finally block that, remember, is always executed, with the only exception of when the program actually finishes, not this way, right? When it finishes using the system.exit. All right, so I reached that finally block. I will see that line printed. This is just printing that number, right? And then I will see a return value being passed here. And now I need to make one observation. That's a new thing that I did not comment before. When you have a return statement inside a finally block, what's going to happen is that that value is going to be returned to the calling context, and the exception handling would be interrupted. So that means that your program would actually go back to the normal flow of execution as nothing actually have happened, as if anything wrong has ever happened, right? So because of that, you would actually have that value be returned by this clause here, and you would see this concatenation here complete, and you would see the overall resulting string be printed by the output, right? So let's see if our predictions actually match here the output. Let me try to run this program, and let's see here my output. But as you see here, you don't see a print stack trace. So that kind of matches what I have mentioned before, right? I even left that comment here just to make sure that you follow that thing. So let's just go back to the top and make sure that the sequence of things that we have predicted actually happened, right? So the first print line that we saw was this one. So we saw this one here. Then here we don't have a print. Here, this would generate an exception. Then I would go here. Then I would print that one. So that's the one that you see here, right? Then I would move on to the finally block. My finally block would throw another exception. So it would leave that. I would not see these printed because I had left that block. Right, so I would go to that catch block here. So again, I generate another new exception. Now I would be calling my print stack. Sorry. I would be throwing an exception. So then the following lines would not be executed, right? So that, again, I leave that catch block, right? So the following lines will not be executed, but I have a finally block. So that finally block will be executed. And you see that happening here. And then finally, you see the return. That was the last thing that I have commented, right? So you would see that return. The last value that you had was 3. So that was when, so you had I equals to 2. Then you incremented that. Then you have that set to 3, right? Am I right? I think so. Yeah. Yeah. So I have that finally as 3. Oh no, sorry. This one actually would not run because of that exception being thrown. So I would actually have that as 2, right? So when I reach this point here, I would increment that, and then these would become 3, and then the value that's going to be returned is going to be 3, right? That's going to be the thing that is going to happen, and you can confirm that that's the case here. And you also see that what I have mentioned in terms of the statement here being able to complete was also true, because you see that line being printed here, right? All right, so that's the last example that I have for today. I think that's possibly the more complex example that we have visited related to these topic of exceptions, right? So it's an interesting exception to play with. So I would highly recommend that you go and keep trying to change, like for instance, the types of the exception and see what happens, right? Try to predict and try to see what would be printed. There's one more thing that I want to comment also, is that just about the use of the print stack trace. When you use print stack trace, that prints to the standard error, so the standard error. The standard error is not the same as the standard output. So these are different streams. So these have different ways to be handled by the JVM and by your operating system. So why am I telling you this? Because the sequence in which you call the print, the out.print, and those print.stack would possibly not be followed in your output. So if you don't see the precise sequence of things that you predict when you are using print stack, that's just because of that. That's just because the print stack trace is using the system error to print the messages, right? So a lot of times you would see that print stack trace actually printing before a previous statement that has actually already been completed, right? So that's something that you would also actually see. We can actually just go and uncomment that, and I can even just quickly show that to you. But as I said before, it's definitely a good idea to just go and and try out those like modifications in your program, right? So you see here that, for instance, my print stack trace was printed. In this case, the very last thing that was printed in this output, right? But that's not the very last thing that's actually is executed, right? So for instance, this guy here is printed, and it goes after this method call here, right? So that's just one example of that asynchronicity that happened that I have mentioned. Okay.